Hi everyone, my name is Dr. Russell Chan and I'm from the University of Twente. I'm presenting on behalf of my collaborators, Associate Professor Rob van der Loop, Associate Professor Martin Immink, and Professor Willem Verwey on a project called ICOME that stands for Individualized Cognitive and Motor Learning for the Elderly. I will show you how we are working towards a guiding framework for enhancing motor learning performance in elder adults. I'm funded from the European Commission's Horizon 2020 program under the Murray Sklodowska-Curry Actions Fellowship. We have an aging society, and elder adults need more help to maintain their motor function. An important problem is that the implementation of motor training programs is not optimized due to costs and other factors. Generic motor training programs can only give average results, and most programs focus only on the physical with very little consideration for cognitive training that has potential for improving motor performance. ICOME is our solution to optimize motor learning in the elderly. We're testing the implementation of two approaches. The first is motor learning should be progressive and tailored to everyone's learning performance. By understanding baseline performances, we can then understand whether elder adults need to learn from shorter, simpler motor chunks before progressing to longer, more difficult sequences. The second is that we're incorporating meditation as a form of cognitive training due to its effects in increasing bottom-up processes aimed to counter the typical top-down dominance in the elderly. ICOME's goal is to make elder adults learn like young adults again. Let me present a few predictions guided by ICOME. When elder adults are performing well and relatively similar to younger adults, then no intervention is needed. This is what we call high-performing elder adults. We predict that cortical activation of motor learning will be low and symmetrical with fast learning performances. In the second best scenario, there is increased cognitive activation, but learning performance is still fast. We predict that meditation as an intervention will help to make cortical activation more symmetrical and reduce top-down activation. In the third and fourth scenario, when learning performance is slower with increased activation, we predict that meditation and variance in progressive chunk learning can help to make cortical activation more similar to the first scenario. In an ongoing experiment, we measured EEG during motor learning and found a brain signal called event-related synchronization in the beta frequency emerges bilaterally close to the motor areas when younger adults gain expertise. If elder adults are responding well to the ICOME approach, then similar brain states are predicted. Thank you for your attention, and we welcome any questions you may have for the North American Society for the Psychology of Sport and Physical Activity Conference 2021. You may follow the project-specific hashtag on Twitter and my Open Science Framework updates. Please email me with questions. Bye for now.